So on your, let me just make sure here. Good. So on your test, if it says something like this, it's usually pretty sloppy. That says okay. Okay. That can mean a lot of things. It can mean it's wrong, but I'm okay with it. Or it's okay because you're following through, and so it started out as a wrong thing, but then you followed through and you're doing it correctly. I'm happy with that. That's okay, right? So as long as you're following through, then I really am just making notes to myself that, hey, I'm okay up to this point, okay? And so if you see little okays, then those might be worth looking into, right? Just kind of, oh, what happened here? Okay. And at the bottom of each page, I put what the total is that you got for that page. And then you'll see that that's what I transfer to the inside page. Now, what I want you to do, because I don't double check that, okay, is make sure that the number at the bottom of the page makes sense and matches what's in the table. Because the table I do double check, so once the number is circled, I've tallied it twice and made sure that it's all good. And that's what I have in my spreadsheet. So if you find any sort of errors, please let me know. And yeah. Oh, everyone always wants to know what the average was. What was the average? It was 53%. It's pretty low. Okay. And so I think we can do better for test 2. Can do it. Okay. And so I will not post solutions. Okay. But if you look through the textbook, you'll find that almost all the questions on the test were from the textbook. Right. And so I like to do that when I can. I know there's a lot of questions in the textbook. But now you know for test 2, okay, if I can do the textbook questions, I'll be okay. Okay. Any questions about the test? Anything weird? Huh? All right. So, like I said at the beginning of the course, this course, we do a little bit of this and then a little bit of this, and they're all very different things. And now we start a completely new, different thing. Okay? And has anyone taken Math 114, business math? Yeah. Then you'll be back in familiar territory. Right? This textbook does use slightly different formulas to do the same thing. Okay, and so we'll just kind of, if that gets confusing, then let me know. But we'll take it in stride. Simple interest is all the same. So mathematics of finance, money math. Right? That's important, of course. Okay. And so chapter 6, and I'll delete this okay here. Chapter 6, mathematics of finance, right? Borrowing money is usually what we're doing. This is on your formula sheet. And again, I brought some spares if you don't have it. It's just these formulas that we'll introduce today. But I do want to fix, I didn't catch it. It should be a capital I. Okay? And you'll see why in the next section when we introduce a lowercase I. And so they'll be different. Okay? But if you just change it to a capital I, I'll make a fresh one for the test, of course. So that's what I wanted to highlight on the formula sheet. But before we talk more about the formula sheet, let's talk about simple interest, which is where we start talking about money. Okay? And so, as you know, probably, if you've ever borrowed money, right? Unless it's from your parents, maybe they're nice and you borrow $200 and then you pay back $200. But the bank doesn't do that for you, right? You borrow $200 and you have to pay back $210. What's that $10 extra? Interest, right? And so it costs money to borrow money. Okay? And of course, if you buy a house, right, then you're paying interest on your loan, right? And it adds up quite a bit over the years. Okay? But unless you have that money in cash, you usually have to borrow it. And so there's that cost of borrowing. So that's what we're exploring today. Okay? Just some terminology. Okay. And so the amount of money that's being borrowed is called the principal or the present value. And so we're going to denote this, the principal or the present value, and we're going to call it P, a capital P, in our formulas. Now, what's nice is where we start, simple interest is paid only on the original amount that you've borrowed. Okay? And so that's not going to make any sense until we see the next chapter or the next section where we have to pay interest on the interest, and it gets a little bit messier. Okay? But for now, we're only paying interest on what we borrowed. Okay? And often, 10%. I am going to have to do that, but I do want to, I want to leave you with some questions to work on, but I have to blab through all the knowledge first, and then I'll run and grab my charger. How about that? So often interest rates are given over a year, okay? But it can be for a week or a month or a quarter. Quarters 4 times per year, right? So per quarter is 4 times per year. Here's what's confusing. How many months in a quarter then? If you take 12 divided by 4, you get 3 months, right? And so don't get those mixed up, right? But every 3 months, you have covered a quarter of the year. If an amount P is borrowed for a time T, lowercase t, at an interest rate of lowercase r per time period. Now that's important. Right? For a time T. I like to have T in years always. So I tend to make that conversion right away if I need to. Okay, but we'll see some examples where you don't have to. So, but T and R have to match. Okay, so if T is in years, then the rate has to be per year, right? And if the time is in months, then the rate has to be per month. Okay? And so here, time and R must match. It went away. It's good. For example, if T is in months, R must be percent per month. I then, capital I, as we saw, I is going to be the amount of interest. So So I is the amount of interest, and how you find it is you take P, the principal amount that you borrowed, times the rate, times the time. Okay? Which, think about it, right? I tell you, oh, you're gonna borrow $100 at 10% per year for 1 year, right? You can do that math. What would you do? You would take $100 times 0.1, right? 10% is 0.1 times 1 year, right? And so then the amount of interest would be 100 times 0.1, which is $10, is what you would have to pay in interest. How much would you have to pay in total? If you have to pay back what you borrowed as well, of course, right? That's going to be what we call the accumulated value, or the total amount. And so we're going to call that capital A, kind of what you have accumulated at the end. Sometimes it's called the future value, right? And so you could call it the future value. And for some reason, we don't usually call it the future value here in simple interest, but we will later on. The accumulated value, right, or the future value, I guess it's here, is given by a capital A. Now you find A is the principal amount that you borrowed, the $100, plus the $10. Oh no, it's really going away here. Plus the $10 that you had to pay in interest, right? What you had to pay to borrow. If you replace I with this formula here, PRT, what you can do is you can pull out a common multiple of capital P, right? And that's how we get this formula here. And this should have an A here as well. Don't have to, but so A is P times 1 plus R times T. And if we go to your formula sheet, that's what's here, right? The future value is A, which is P times 1 plus R times T. How we got there, I think I'm going to swap, since I'm making changes anyways, maybe I should swap the order of these, because we didn't introduce them in that order. Right? We introduced I, the amount of interest, PRT, for the amount of interest is the accumulated amount minus P, right? Or you could swap those around. A then must be I plus P, right? Or P plus I. Lots of ways that you can rework it. And then we get to the future value. Now, because I have to grab my charger, I'm going to move up some questions so you can work through them, and then I'll run way over to my office. See how far you get, and then we'll work through them together. I am going to pause this recording though, because like nothing happened. And really nothing happened because you couldn't do anything. That's what I'm hearing. Sorry about that. Okay. Let's see here. All good there. Then I won't do this pile up. I'll move them back down. We can focus one at a time. Okay. So when you're solving these problems, then you want to keep an eye out for a couple of things. First, try to figure out what information you've been given. Of course, that's a good place to start. Okay. And then the next thing that you want to make sure is that your time and your rate, right? Those time periods match. Otherwise, you'll need to adjust either the time or the rate to make them match. Okay? Like I said, I always like to just force them to be per year, right? But I'll show you that you can do it either or. Okay. And so I'll say 1, identify given information. In this case, Ursula borrows $600. That's going to be your principal amount, right? So that's going to be your P, the amount that you've borrowed. Okay. And we're told for 5 months at a simple interest rate of 15% per year. Okay. And so T is 5 months, and R, what you want to do with R right away is just convert it to a decimal. And because we don't do math with the percentages, we only do math with the decimals. Okay, so 0.15. Always convert R to a decimal. But it's 15% or 0.15 per year. So these need to match. 5 months and 15% per year. Now what you could do is you could divide 15% by 12, right, to get it per month. Okay. Or I think it might be easier in this case to say, right, or 5/12 of a year. I know there are 12 months in a year, and so 5 months is 5/12 of a year, right? And then all of a sudden I have it in years and I have the rate in years, and now I can proceed. Right? And so that's the tricky part. Okay. Oh, my screen went dark. It's weird. Or if you wanted to keep it at 5 months, you would divide the 0.15 by 12. Okay. So, or, let me see here. We need T and R to match, right? And so T can be 5/12 of a year, with R staying at 0.15 per year. Oops, pair. I combined the two words, per year. Or T can be left at 5 months, but then R you would need to, or 0.15 divided by 12 per month. Right? So notice here, per year, month, or month. You have to pick one of those two. Right? We can do it both ways. Right? Make sure that they end up being the same. Huh? So let's do a little divisor here. Huh? Only for the first one, just because I want to show you that it doesn't matter which one you choose, right? You'll get to the same answer, huh? But they do have to match. We wanted to find the interest and the total amount she's obligated to pay. And so what that means is we want to find I, the amount of interest is what it should say, and the total amount, which is A. Remembering that A is really P plus I, the only math we need to do is find I, And then for A, we just have to add it to the initial $600, right? And so we'll work on finding I. Now from your formula sheet, like I said, we're going to change it to a capital I, right? But I is PRT. And it's your job to remember that, okay, R and T have to be in the same kind of time reference. And then I is A minus P, right? But you can rearrange that however you want. So let's do I is PRT and I is PRT. As an exercise, we'll do them both. P is the same for both of these, right? She borrowed $600 in both scenarios because they're the same. So 600 times, and in this case, we're going to keep R at 0.15. And T is 5/12 of a year, right? Or 5/12. We use our calculator. Phew. Packed my calculator. I always bring my calculator. Not my charger, I guess. So 600 times 0.15 times, and I'm going to put brackets 5/12 and brackets. And I get 37.5. Now for monies, yeah. Uh, 5/12, I just was lazy. Oh, it seemed it's a repeating decimal. So if you keep all the decimals in your calculator, like if you do the 5/12 and then multiply through, that should be safe. But otherwise, you want to make sure that you keep all the decimals. For example, if you did just, because this is 0.41666 repeating. So if you rounded to 0.42, for example, 0.42 times 0.15 times 600, you'd have to pay 30 cents more in interest. And people don't like that, right? And so that's the reason. So for money, always keep all your decimal places. For money, keep all decimals. And another money thing, since we're spending the whole chapter working with money, it's good to get these kind of rules out of the way. We have 2 decimal places for money. No more, no less, but not until the final answer, right? And so here, as money, $37.50. And let me just give us a little bit more room. Now we should find the same answer on the other side, right? But let's just make sure. And so, oh, and another thing, I can't remember if I pointed it out. If nothing's changing on one of the sides of the equal signs, then you don't need to write it down, right? So here, this is just I. And then sometimes it's nice to throw in a final I at the end here, but it's not necessary. So that's the amount of interest that Ursula is going to need to pay. That's why it's a dollar amount. If we look at it in a monthly form, right? So now T is in 5 months, but the rate, I have to do a conversion, 0.15/12 times 5. And I'll tackle that fraction first. 0.15 divided by 12 is 0.0125 per month. And then times 600 times 5. Well, looky here. 3750 again. What's really nice about just multiplying and dividing is it doesn't matter which order you do them in, right? And so what you could have done is you could have taken 600 times 0.15 times 5 divided by 12. Crazy, right? But that's also the reason why these answers are the same. I'm dividing by 12 here is the same as divided by 12 here. Right? Nice. So whichever way you prefer is fine, but you have to make sure that the R and the T's match. And therefore A, which is P plus I, P was 600 plus I, which is 3750. $637.50 is the total amount that she would need to pay back. All right, first the 600 that she borrowed, plus the interest that it cost her to borrow it. Ursula would need to pay back $637.50. Nice. But this one, Jose deposited $2,500 in an account that pays. Oh, that's nice. That can happen too if you have a high interest e-savings account. If you go to the bank, they're always trying to get you to open one of those, right? And so then you get money. They borrow your money, so they have to pay you. That's nice, right? Usually it's a little bit lower. a lot lower than what they take, but still it's better than nothing. So he deposited $2,500 in an account that pays 6% simple interest. If it doesn't specify, it's per year. So here, per year, if not specified. How much money will he have at the end of 3 years? So that's nice. Now the rate is per year and the time is in years. So we don't need to worry about that, but we'll always remember that we need to worry about that. And then we're relieved when we don't have to. So here, let's see, what have we been given? Now this P, the principal amount, can be the original amount that you borrowed or invested, right? It's your starting amount. And so P in this case is 2,500. R, I'll do them as they appear here, right? R is going to be 0.06, right? Dividing by 100. And I'll clarify per year here. And T is 3 years. All right. First thing we want to do, year, check. They're the same. How much money will he have at the end of 3 years? That's the accumulated amount, right? He still gets to keep his $2,500, and the interest that he's made. And so here, how much money will he have means find A. Should we try that other formula? You can go ahead and you can find I and then add it to P if you wanted to, right? Or we can get fancy. If all we're looking for is A, we can use this little guy here, which is on your formula sheet as well. I'll bring it in. Notice that it uses the same information, just in a different format, right? We need P, we need R, and we need T. And so, but once we have those things, which we do, then we can solve for A. So whenever we only have to find A, this is going to be a slightly quicker option, just slightly. Right? So it's up to you. Now, A is P times 1 plus R times T. It's important that you solve R times T first, then add it to 1, and then multiply by P. Right? And so how you're going to work through this is multiply this, R times T, and then add it to 1, and then multiply by P. Yeah. So you want to start in the center and work your way out. P, we can plug in our numbers, is 2,500 times 1 plus 0.06 times 3. Starting with 0.06 times 3, one plus 0.18. And then 1 plus 0.18 is 2,500 times 1.18. And then times 2,500, I get $2,950 even. How much did he make in interest? Which would be I. Nice. How much did he make in interest? I is A minus P. That's on your formula sheet. It's the one that we can kind of rearrange to be whatever we want it to be. I'll say since A is P plus I, right? A minus P is I, right? And so you can rearrange this and solve for whatever you want. Of those three, of course. So I, what you probably did in your head is 2,950 minus 2,500, but that's the reason. $450. Pretty good. Took 3 years, but still. Any questions about that one? Yeah. Is that good? Nice. I should know better by now. Good. How about this one? Darnell owes a total of $3,060, okay, which includes 12% interest for the 3 years he borrowed the money. How much did he originally borrow? Let's talk about what we want to solve for first, because that might help us identify what's been given. Right, and so how much did he originally borrow? That's your P, right? And so we want to find P. Knowing that we need to find P, that's a clue to me that says, okay, this $3,060 can't be P because I want to find P, so it has to be A is more likely, right? And so let's confirm. So Darnell owes a total. Okay, I feel pretty good about this being A. So we're given A is $3,060. And R is 0.12 interest. And I'm going to clarify per year. Huh? But doesn't say then it's per year. You can assume it's per year. Huh? And T is 3 years. First thing you do, make sure that these are the same. Yeah.
It says 12% interest for the 3 years, so would you not do 12 divided by 3 and then it'd be 4% interest?
I default to the per year. I could be convinced because it's not clear to me.
Okay.
I didn't bring the textbook to check. And I don't think I have it nearby. I'll have to double check though, but how I read it, it would be the 12% per year.
Yeah, if you're.
Oh, nice. Phew. Oh, hey, what happened? My iPad just wants to sleep. It's being lazy. Oh, hello? Okay, let me just, it's gonna be the weirdest recording there ever was. Share my screen. I don't know why it keeps, it's plugged in now, it should be happy. So needy. There, pause. Okay, good. So they do just keep it at 0.12 per year?
Yeah.
Okay, so then like I said, I could be convinced, but how I read it is just 12% per year. If it doesn't say, it's just per year. Oh, nice try. Okay. We have A, we have R, we have T, and we want to find P. I think the easiest formula to use is probably going to be the A equals P times 1 plus R times T again, but solving for P. We can do that. 3060 is P times 1 plus 0.12 times 3. Same as before, you want to make sure that you do the 0.12 times 3 and then add it to 1 before you do any other manipulations. And so let's do 0.12 times 3. 1 plus 0.36. 1.36. And in this case, I'll carry the 3060 down. Dividing both sides by 1.36. $30.60 divided by that guy. Oh, I did it wrong. 30.60 divided by 1.36. I divided by 0.36 and I got $8,000, which doesn't really make sense. $2,250. That makes more sense. How much did he pay in interest? Yeah, a lot. I'll use my calculator. How much did he pay in interest? Oops. I is A minus P. A was 3060 minus 2250. Better have been worth it. $810. A Visa credit card company. Oh, whoops. I'm learning. I guess I can still see it. A Visa credit card company charges a 1.5% finance charge each month on the unpaid balance. I feel like usually it's like 20% or something crazy, but yeah.
I wish you would.
Yeah, be nice. Then they'd never get their monies back. Yeah. If Martha owed $2,350 and has not paid her bill for 3 months, how much does she owe now? Uh-oh. So every month she has to pay 1.5% on the $2,350. Okay. First, let's figure out what we need to solve for. Okay. How much does she owe now? That's the total, that's the A, right? The accumulated amount. So we want to find A. Okay. And what are we given? In the order that it appears, we're given that the rate is 0.015, right? If you do 1.5 divided by 100, you should get 0.015. You want to make sure that you have the right number of zeros. Each month, per month. If Martha owed $2,350. That makes that the P, right? The original that she borrowed, let's assume 2,350, and has not paid her bill for 3 months. First thing we need to do is make sure that these match up, which they do in this case. Okay, and we want to solve for A. And again, whenever we want to find A, the go-to move should be A is P times 1 plus R times T. If P is $2,350 times 1 plus 0.015 times the 3 months. Starting with the 0.015 times 3, inside here, 2,350 times 1 plus 0.045. 2,350 times 1.045. Can I squeeze it onto, oops, plus 1. Good. Times 2,350. And what's nice is this gives me 2 decimal places just naturally. Otherwise, you'd want to round properly to 2 decimal places, right? At the very, very end. We can figure out how much she paid in interest, right? Well, it's the difference between how much she owes and the 2,350 that she started with. So I'll just do it here, where I is A minus P, just so that we can get flexy 24, 55, 75, moving between these values, right? They're always related. $105.75. That's only for 3 months. Eek. It's a lot, I think. Yeah. Nice. I feel like there was something else I was going to say here before we move on. I guess not. Maybe it was just writing it out as a question. Find the amount of interest. Ah, I remember now. But it's actually to lead us into Monday. What we'll learn on Monday is compound interest, right? And so here, she borrowed $2,350. And for each month that she doesn't pay, they just say, oh, we'll just add on 1.5%, 1.5%, 1.5%, right? And so what would happen with compound interest, which is usually how banks work, is for the first month, you would pay the 1.5. So we could find A after 1 month. Here, let's add a page. What if each month the amount of interest was added to the principal amount? This is called compound interest, which we're introducing on Monday, but I think this is a really nice example. So you can think about the difference between the two over the weekend. Wow, how nice. What would that look like? So after 1 month, you have to pay 1.5, right? And so here, after the first month, A is P times 1 plus R times T. P is 2,350 times 1 plus 0.015 times 1 month. So after the first month, she would need to pay 0.015 times 1 plus 1, and then times 2,350. She would owe $2,385.25. Now, for the second month, how compound interest works is now she would have to pay interest on this as the principal amount for the next month, and then the next month, and you can see how it compounds, right? It adds up. That's what compounding means. So then at the second month, P becomes 2385.25 from here. So now A is P times 1 plus R times T, still doing. So then after the second month, now only a month has passed, right? So T will still be 1. That's the difference. A is 2,385.25 times 1 plus 0.015 times 1. Okay. Times 1.015. I get 2,421.02875, or in money, 2421.03, rounding to 2 decimal places. What did she have to pay with simple interest? Well, we're getting there. How about after the second month? Or sorry, after the third month? Now, to the bank says, well, actually, now you've borrowed $2,421.03, so you have to pay interest on that now, right? And so this A kind of turns into the P for the next month, right? And so here, after the third month, A is P times 1 plus R times T, where this becomes your P, 2,421.03 times 1 plus 0.015 times 1 more month. Just 1 more month. I'm curious. Okay, not that much more expensive. 2,457.3448181. In money, 24.57, 34 pennies. So if the interest was compounding each month, right, then you would have to pay $2,457.34 at the end of 3 months versus, what was it? Versus, I'll just copy it here so I don't have to remember. Copy. With simple interest. Now, the difference here, right? You would think that, okay, if you're paying interest on the interest that you owed, right, then it'll get bigger pretty quickly. And it will as time goes on, right? Then compound interest does add up faster, right? And so, but there's, that's the difference between simple interest and compound interest. Kind of a leading you into class on Monday. Bringing you back to today, discounts and proceeds. And so usually what happens, or often what happens, not, I shouldn't say usually, but often what happens is the banks take the amount of interest that you will be paying before they give you the money that they're going to lend you, right? And so if you go in and you say, I want to borrow $100, and they say, great, but you'll have to pay interest. So we're going to take $20 and here's your $80, right? And so, so that's what the discounts are. Okay? And so when they do that, which is, I think, pretty rare, usually we pay the interest as we go, but we say that the loan has been discounted. Okay? And so the interest that's deducted is called the discount. And then the actual amount that you get is called the proceeds. And the amount that the borrower is obligated to repay is called the maturity value. Now, what I will make a note of here is note. You'll have to do some assignment problems, right? Some practice problems using discounts and proceeds, but I'm not going to put it on a test. Okay. And so only kind of this stuff and up will be tested, okay, in terms of simple interest. But since you have to do some assignment problems on this stuff, we'll talk about it. But that's why we're not going to spend a whole lot of time here. Okay? Because it's also just more terminology and it's kind of confusing. So discounts and proceeds proceeds will be on your assignments or assignment, but not tested. Okay. Which also explains why it's not on your formula sheet. Okay. Oops. So you can kind of try your best, see how it goes, but don't worry too much about it if you find that it's harder than the other stuff we did. So if an amount M is borrowed for a time T, now M kind of corresponds to our previous P, the principal amount, time T at a discount rate of R per year, then the discount, this looks a lot like I equals PRT to me, right? And so here, versus I equals PRT. To me, they're the same, right? If M is the P And D is the I, the amount of interest that you have to pay. And it's the discount. The proceeds P, the actual amount the borrower gets, is going to be, so this is the same P, the principal amount, is the amount that they borrowed minus the discount. Right? Versus P equals A minus I. Or you can rework it just like we did with A. P is M minus M times R times T, just replacing the D with MRT. But notice, right, this is not on your formula sheet, so it might be nice to have these handy for your assignment questions, but not on your formula sheet. Francisco borrows $1,200 for 10 months at a simple interest rate of 15% per year. Determine the discount and the proceeds. Okay. So we want to find D, which is the discount, and P, the proceeds. Well, we'll do the same thing that we did before. We're given how much he borrowed. Now, the amount borrowed is M in this case, right? Because we know that it asks for the discounts and the proceeds, I know I'm going to be working in this kind of formula section. And so I want to map all the given things to these formulas. And so an amount M, capital M, is borrowed. Okay? And so Francisco borrows M equals 1,200. For T equals 10 months at a rate R of 0.15 per year. As always, we want to make sure that T and R match up. Okay? I always think, right, that the easiest fix is to take 10 months and do 10 over 12. Right? Or if you want to divide the rate per year into per month, that's doing the same thing. I'm going to use T equals 10/12 of a year. 10 over 12 years. Yes. To force them to match. Oh. Okay. Now, if we want to find the discount, we can find it by M times R times T. We have all these three things, so that seems like a reasonable place to start. D equals M times R times T. 1,200 times the rate, 0.15, times T, which in this case, I'll use 10 over 12. You can try it with the converting the rate to be per month if you want, but you'll find the same answer. I'll start with 10 over 12, which is nothing nice, so I'm just going to keep it there, times 0.15 times 1,200, which is $150. So that's how much the bank is going to withhold and say, hey, you already owe us $150. You've committed to paying us $150. So we're just going to take that right away. Okay? And then what you get, the proceeds, is going to be the amount minus the discount. So therefore, P is the amount minus the discount. What did we, 1,200 minus 150? Let me just make sure. So D is 150. And then P, so what you actually get to borrow and use is $1,050. Held by, I'll just clarify here because I find that this stuff is kind of confusing. Held by the bank, right, as before they loan you money. I'll put this down here. Before they give you money. And then this P is the amount you actually get to borrow. What if you're Francisco and you say, well, I didn't want $1,050. Hey, I told you I needed $1,200. I wanted $1,200. Then what would the bank say? Well, then you would need to borrow how much? And that's our next example. So if Francisco wants to receive, right, 1,200 or 1,200 for 10 months at a simple interest rate of 15% per year, so same criteria, what amount of loan should he apply for? So here we want to find M, right? Where we're given that the proceeds that he wants, so what he actually gets, he wants to receive 1,200. T is, but we already know that 10/12ths of a year because we already did that work. And the rate is 0.15 per year. I have P, T, and R, and I want to solve for M. So from my formulas, I need to find a formula that has those things. How about this little guy here? P is M times 1 minus R times T. Notice the minus, right? Before it was a plus. P equals M times 1 minus R times T. I'll highlight that. Because you have to deduct the discount. That's why. We want to solve for M, but we can do that. 1,200 is M times 1 minus 0.15 times 10/12ths of a year. Starting with 10 over 12, then times 0.15. Oops, did it wrong. I'll show my work here. 1 minus 0.125. One minus that is 0.875. So M must be 1,200 divided by 0.875. $1,371.428571. So the amount that he would need to borrow to three decimal, or sorry, I was reading the 3 to 2 decimal places, right? That's important for money. You have to round to 43 cents. So they said, oh, well, you actually wanted 1,200. Well, then you'll have to borrow 1,371 and 43 cents. And that's the difference between kind of paying it up front, paying the interest up front, or usually what we do is where we started, where you accumulate and you have to pay off the interest later. And I think that's all I have for this section. Let me see what time it is. Oh, that's fine. It's been quiet over there for a while, I think. It makes me nervous, but then I'm like, no, I think I got time. But any questions? No. Then I'll let you do whatever you want. I'll be here if you want me to be here. Otherwise, enjoy your weekend. I'll see you on Monday.